Okay, so this next video is going to be for problem number 2 for test 3. This is when we're dealing with the torque and the static equilibrium of a leg, and basically this highlighted portion, you have the weight of your leg and the weight of your foot acting on the knee joint essentially, which is your pivot point. And then you have this tendon that's working also to add a force that's going up to like 25 degrees from the line of the leg. So this is kind of more like the physics-y view of it. So there's a 40-degree angle. This is what W is the weight force of the leg. F is the force of gravity acting on the foot. And then you have the tension from your tendon coming up. And they basically want you to find the tension when the tendon is at an angle of 25 degrees. So this is the calculations I did for it. So I kind of drew out my own free body diagram here. I don't know what T is. I know what the weight force is 30 newtons, and I know that the force of gravity acting on the foot is 12.5 newtons. That should have an arrow over it, but whatever. Hey, Mac. 1 second, be quiet, okay? Thank you. So this is the drawing. I know the equation for torque in a static equilibrium is that the net forces have to be equal to 0 and the net torque has to be equal to 0. We learned from our lecture in the textbook that torque is equal to the radius times the sine theta of the force. And so using that, basically this is just another drawing I did to make more sense of this. Oh, this is important too. I should say this. So the tendon attaches and acts at 1/5 the length of the leg. So 1/5 of the length of the leg is right there. This is the length, the whole length. The weight force acts at half the length of the leg, and then F acts at the entire length of the leg, if that makes sense. That was also important in the question. So if I'm gonna do using this equation for torque, I'm gonna basically find the torque that's what am I trying to say? The torque that's generated for each of these forces on the knee joint here. And I don't have to worry about any forces on the knee joint because obviously the radius or the distance away from that is 0, so there's no going to be forces acting there. So the torque of the weight of the leg is going to be negative 10.5 L. Why is it negative 10.5? Oh, that's not negative. Oh my gosh. So that's 0.5 to say that it's 1/2 of L. But it's negative because the weight force would be causing a torque in the clockwise direction, which makes it a negative torque. So that's super confusing, but that's just a negative. So that's 0.5 L times W times the sine of 40, which is the degree here, theta, is going to give me negative 9.6418 L. And then I have the torque of the force of the foot of gravity acting on the foot is also going to be negative L, which is the whole distance, times 12.5. We could just put 1 there. Times 12.5 times the sine of 40 is going to give me negative 8.0348 L. And this is negative as well because it's going to force that torque motion in a clockwise direction. And then the torque from the tension of the tendon is going to be 0.2 L, and that's just 1/5 L. So 0.2 L times the force, which I don't know, times the sine of 25. And that gives me 0.0845 LT, okay? So the deal is that if the sum of all these things have to be equal to 0, right? So that's kind of the deal with the static equilibrium, which I'm assuming the question is in. It doesn't really specify, but that's the only way this makes sense. So you end up with this minus this plus this should be equal to 0. So these all have an L factor, so I just factored L out of it, and then I divided by L, and then 0 divided by L is just not 0, so then I'm left with T. And so I can solve for T. I combine these terms, which was negative 17.6766, and I added it over here, and then I divided by 0.0845, and I should isolate for T, and T would be 209.19 newtons. So the tension in that to make it so that there's no net force is 209.19 newtons. And then I want to say that's like around 50 pounds I looked up, which seems like a lot of force, but then if you think it's like 50 pounds of force, it makes sense that you would have that much force acting in your tendon to keep your leg up. So that should be the answer. So the tendon tension is 209.19 pounds right here.